Hello ASVAB warriors, welcome back to your Arithmetic Reasoning class. In the previous video of this topic, we have seen the concept of distance, rate and time, how to calculate distance, rate and time. Now, in this video, we will be learning new concept of relative speed. What is relative speed? Let us understand. Now, the definition of relative speed is relative speed is the speed of one object as observed from another moving object. Let's say there are two vehicles or two objects. When they are approaching towards each other or moving away from each other. Now you must have seen these kind of questions in your ASVAB papers, that one vehicle is going at a particular speed and another vehicle is approaching towards it with another speed. Then what will be the relative speed, or when will the two vehicles catch up with each other? If let's say another question will be, from point A vehicle starts and after a particular time vehicle B starts and they are going in the same direction. When will the vehicle B catches up with the vehicle A? That kind of question you will see in your ASVAB papers. And how to solve these questions? That is what we are going to learn in this video. So let us see how to figure out how to calculate the relative speed of the vehicles when they are moving away from each other or approaching towards each other. Now we have two formulas. First one is when the vehicles are moving in the same direction. Now for the same direction, we have the formula for relative speed. Speed of the object 1 minus speed of the object 2. We will have to take the difference between the speeds. Obviously, if the two vehicles are traveling in the same direction, one might be traveling at a x speed and another might be traveling at a y speed. And to calculate the relative speed of them, we will have to subtract the speed of object 1 from the speed of object 2. So we will take an example to understand this. Now the example is, two cars are traveling on a highway. Car A is moving at 70 miles per hour and car B is moving at 50 miles per hour. In the same direction, the relative speed is. Now we have to calculate what will be the relative speed. There is a highway and car A is traveling in this direction at 70 miles per hour and car B is traveling at 50 miles per hour in the same direction. So car B is also traveling in the same direction, that is this direction. The speed of the vehicle B is, or the car B is 50 miles per hour. Now we have to calculate the relative speed. The formula for relative speed is speed of object 1, which is 70 miles per hour, minus speed of object B, which is 50 miles per hour. So relative speed will be 20 miles per hour. Now how do you see the relative speed in the real life? Now let's say if you are sitting in the vehicle B, then you will see that vehicle A is approaching towards you at a speed of only 20 miles per hour, because you are already traveling at 50 miles per hour and another vehicle is coming towards you with the speed of 70 miles per hour. So this is how the concept of relative speed works. Now we will see another formula. Now we will understand this formula by taking a simple example. Now this is the same example which we have taken in the previous slide, but the vehicles are traveling in the opposite direction. Now two cars are traveling on a highway. Car A is moving at a speed of 70 miles per hour and car B is moving at a speed of 50 miles per hour in the opposite direction. This is very important word. The relative speed is, the vehicles are traveling in the opposite direction. We know the formula, which is speed of object 1 plus speed of object 2, which gives us relative speed. So what will be relative speed? So relative speed equals to speed of object 1 which is 70 miles per hour, and speed of object 2, which is 50 miles per hour. We will add both the speeds. So 70 plus 50 will be 120 miles per hour. This will be the relative speed for the two vehicles. Now the question might be, how long will it take for both the vehicles to meet at a certain point, or these type of questions you will be facing in the concept of relative speed. Now let's move on to the next slide, where we will be solving few questions on the concept of relative speed. Now here is the question on the concept of relative speed. Now the question says, a car leaves city A and travels at 40 miles per hour. 2 hours later, another car leaves city A traveling at 60 miles per hour in the same direction. How long will it take the second car to catch up with the first car? Now the question is, car A leaves the city A. Let's say this is city A, and car A is traveling with a speed of 40 miles per hour, and 2 hours later another car leaves city A. So let's say there is another car leaving this city, but after 2 hours. Now in these 2 hours, how much distance this car A will cover? Now in these 2 hours, how much distance will this car cover? We have the formula. Distance will be equal to speed into time, or rate into time. So what is the speed? Speed is 40 miles per hour, and it is traveling for 2 hours. So 40 times 2 will be 80. So the distance covered by this first car will be 80 miles. And then after 2 hours, car B or another car leaves the city at speed of 60 miles per hour. So speed of this car will be 60 miles per hour. Now this car has the advantage of 20 miles per hour. How? Because we know the concept of relative speed. So relative speed is speed of the car A minus speed of the car B. Here in this case, speed of this car is more. So 60 miles per hour minus 40 miles per hour. So we get our relative speed as 20 miles per hour. So this car has advantage of 20 miles per hour. Now to catch up with the car A, this car will have to cover this distance, which is 80 miles per hour. This was the distance already traveled by the car A. So to cover this distance of 80 miles, this car B will take how much time? So we will divide this distance, which is 80, by this speed, relative speed, which is 20 miles per hour. So 80 divided by 20 miles per hour, we will get 4 hours. So for car B to catch up with the car A, it will take 4 hours. So this will be our answer. Let's take another example. Now this example says, 2 cars leave a city heading in opposite direction. One travels at a speed of 55 miles per hour and other travels at speed of 65 miles per hour. How far apart will they be after 4 hours? Now let's say there is a city and 2 cars travels in the opposite direction. So let's say car A goes this side and car B goes this side. And one travels at a speed of 55 miles per hour, while another travels at a speed of 65 miles per hour. And they travels, or we have to calculate the distance between them after 4 hours. It means these cars will be traveling for 4 hours, both the cars. Now there are 2 ways to solve this question. First one is, we will calculate distance traveled by this car and distance traveled by this car, and then we will add them. Or you can take the concept of relative speed. You will have to calculate the relative speed, and by using this speed you can calculate the distance traveled, because we have the time given as 4 hours. So we will see both the methods. Now first we will calculate the distance traveled by this car. So formula for distance is rate into time, where rate is 55 times 4. 4 5s are 20, carry 2, again 4 5s are 20, plus 2 is 22. So this car will cover distance of 220 miles, and for this car we have distance equals to rate into time. Here rate is 65, time is 4 hours, same. So 4 5s are 20, carry 2, 6 4s are 24, plus 2 is 26. So this car will cover distance of 260 miles. But this car is traveling in this direction and this car is traveling in this direction. So total distance covered will be 260 this side plus 220 this side. So 220 plus 260 will be 480 miles. So this is the total distance covered. How much it is? 480 miles. And we will solve it using the concept of relative speed. How do we calculate relative speed? When the vehicles are traveling in the opposite direction. When the vehicles are traveling in the opposite direction, we just add the speed of each vehicle. So which is 55 miles per hour plus 65 miles per hour. 5 plus 5 is 10, carry 1. 6 plus 5 is 11 plus 1. 120 miles per hour will be the relative speed. And these cars are traveling for 4 hours. So we have to calculate distance. Formula for distance is rate into time. Rate is 120 miles. We have to use the relative speed or relative rate. And time is 4 hours. So 12 4s are 48 and this 0 as it is. So we get our answer as 480 miles. Is it same in both the cases? Yes. It means our concept of relative speed is correct. Let's take another example. Now the example is two trains are traveling towards each other on the same track. Train A travels at 60 miles per hour and train B travels at 40 miles per hour. If they are 20 miles apart, how long will it take for them to meet? There is a track, and on this track train A is traveling at 60 miles per hour speed and train B is traveling at 40 miles per hour speed, and they are traveling towards each other. So what will be the relative speed? We will have to add them. So relative speed will be equal to speed of train A, which is 60 miles per hour, and speed of train B, which is 40 miles per hour. So relative speed will be 100 miles per hour. And if they are 200 miles apart, how long will it take for them to meet? Now we need to calculate to cover this distance, how much time will both the trains take. So we will have to take the relative speed and distance as 200 miles. So we have distance 200 miles, speed or rate is 100 miles per hour. What will be time? For time we have the formula, which is distance divided by rate. Here distance is 200 divided by rate is 100, so time will be equals to 2 hours. So both the trains will take 2 hours to meet each other. I hope you understood this question. Let's take another example on the same topic. Now the example is a faster train traveling at 80 miles per hour starts from a station 2 hours after a slower train traveling at 50 miles per hour. How long will it take for the faster train to catch up if the slower train has already travels 100 miles when the faster train starts? Now, the slower train has already started, and after 2 hours this faster train will start, and in these 2 hours the slower train has covered the distance of 100 miles already. Now we will take the concept of relative speed. What will be relative speed in this case? Here they are traveling in the same direction. So for the case of same direction, we will take difference between their speeds. So first one is 80 miles per hour minus 50 miles per hour. So relative speed will be 30 miles per hour. It means the faster train is traveling with the advantage of 30 miles per hour. Now, but meanwhile, the slower train has covered 100 miles per hour of distance, and this faster train will have to catch up this distance. Now to cover the distance of 100 miles, how long will this train take? So time equals to distance divided by rate. Here distance is 100 miles and rate is 30 miles per hour, which is the relative speed. So 100 divided by 30, which will come out to be 3.33, or we can say 3 1/3 of an hour, or we can say 3 hours and 20 minutes. How 20 minutes? We know that 1 hour has 60 minutes and 1/3 of 60 will be 20, so 20 minutes. So the faster train will take 3 hours and 20 minutes to catch up with the slower train by covering this 100 miles of distance as well. Let's take another example. Now this is the question of boat and current. Now while solving the question of boat and current, you have to remember 2 points. Either the speed will be downstream, or speed will be upstream. What does the downstream means? The boat is traveling with the current, with the current or in the direction of the current, and upstream means the boat is traveling in the opposite direction of current. When the word downstream is used, we have to take the relative speed by adding the speed of boat to the speed of current. This will be the relative speed in the case of downstream, and in the case of upstream, we will have to subtract the speed of current from the speed of boat. You will have to subtract the speed of current from speed of boat. This will be the formula for relative speed in case of boat and current. Now in this particular case, we have the question of downstream. A boat travels 20 miles downstream in 4 hours. What is the speed of the boat in still water if the current is flowing at 2 miles per hour? Now let us assume that the speed of boat in still water, still water means there is no current, and this speed we will assume to be B, and the speed of current, let us assume speed of current is C, which is given as 2 miles per hour. Okay. Now what will be the speed of boat downstream? We know that for downstream we have the formula speed of boat plus speed of current. Here speed of boat is B and speed of current is 2. So the downstream speed will be B plus 2 miles per hour. And we have been given that boat travels 20 miles in 4 hours. Distance traveled is 20 miles time taken is 4 hours. What will be the speed? We have the formula for speed, which is distance divided by time. The distance is 20 and time is 4 hours. So speed will be 4 5s are 20. So 5 miles per hour will be the speed. And we also have the downstream speed as b plus 2. So we will equate them. We will equate downstream speed with this speed. So b plus 2 equals to 5 miles per hour. So b will be equals to, we will send this plus 2 over to that side of equation. So it will become minus 2. So b will be 3 miles per hour. This will be the speed of boat in still water. So we have to calculate the speed of boat in still water. It will be 3 miles per hour. So b will be 3 miles per hour. Okay, I hope you understood this question. That was it for the day, guys. In the next video, we will be solving mixed problem based on the concept of distance, rate and time, and also on the relative speed. I am your reasoning coach Shubham, signing off. Do like, share and subscribe to our YouTube channel ASVAB Warriors. Thank you so much.